Hello class, let's take a look at example 1. So this is the idea. So they're telling us that the data is actually bell-shaped. So they're saying it's normally distributed. Let me highlight that portion. And then the most important part of this is the following parameters. So we're given that the mean of the distribution is 172 pounds for the weight of males and the standard deviation being 29. So as we actually evaluate this particular one, well, don't forget about declaring the variable. In this situation, the variable is going to represent, well, the weight of an individual. And then as we actually evaluate the probability, we're looking at greater than or equal to the values of 80. Now, let me give you the code for this one. So as we technically evaluate this particular probability, you're looking at the following. So we're going to be looking at the normal distribution, in this case normal CDF. Now they're asking for a value greater than 80 pounds. So your lower bound, it's going to be 80, comma, a very large value. And then don't forget about the values of mu and sigma. So 172. And then the standard deviation is actually the values of 29. So please take a second. Here you have the code to evaluate this specific probability. Please check and see if you're actually matching. So in this scenario, I'm getting 0.99. Let me check it again. So I'm getting 0.9992, which is technically approximately 1. So for this particular problem, it's back to section 7.1, 7.2. We're still dealing with a single individual, in this case, a single individual, as we're evaluating from the normal distribution. So let me just wait here a second and see if everybody matches with the outcome before we go to actually part B. Okay, as we go to part B, they haven't mentioned anything regarding more than a single subject. So in this situation, we're still talking about a single individual, and the actual probability of the event that we're evaluating is from 200 to 230 pounds. So let me run it again. In this case, let me clear it. So for this one, we're running again the normal CDF, except that your parameters are going to be for the lower bound 200, then 230 for the upper bound with 172, and technically the problem is given that 29 is the standard deviation. So please take a second and run it and see if you're matching. I'm getting on this one approximately 0.14. I'm running to 4 decimal places, so 1444. And so far for both of the previous problems, they're looking for a single individual. Now let's go to technically the new portion of this section, and this is basically part C. And in part C, they're changing it a little bit. Now they're not talking about a total 20 individuals. So we're gonna actually be evaluating a new C-score, and in this case, you're looking at 20 individuals. The probability that they're asking us to do, it's 180. So greater than or equal to 180. And for this particular one, we have a couple of options. You can technically change all the values of the C-scores to technically your group data. So as you evaluate it for the group data, I'm looking at the following. So the values of x is 180 minus mu 172. And once again, those values are from the actual parameters of the distribution. And if they want you to change to a z-score, you're basically dividing the values of 29, which is the standard deviation, by the square root of n, which in this case is 20. Now, please take a second and see if you're matching to approximately 1.23, which happens to be your actual z-score. Now, at this point, we're rewriting the statement as the values of basically x is greater than or equal to 180, but remember that this is for 20 individuals, which in terms of a z-score, it represents the values of c is greater than or equal to 1.23. So please evaluate this one with 1.23. Now, remember that if you're evaluating the distribution, in this case, normal CDF, this is 1.23. We just need a large upper bound. But remember that, well, since we changed the values of x to z-scores, the values of mu happens to be 0, and then technically 1 happens to be the standard deviation. So please run it and see what you're getting. For this particular scenario, I'm getting 0.1093. Let me show the calculator again. So we're getting 0.1093, which happens to be the probability that in this case 20 subjects happen to have a mean greater of 180 pounds. Now, this portion that we did here, which is changing the actual x value into a z-score, it's not necessary, and they're actually not asking that in the problem. So what you could do is ultimately run the shortcut, and in the shortcut you're adjusting basically the values of mu divided by sigma. So this is how you do the shortcut on this particular one if the problem were to say use technology. So you're looking at 180, which happens to be your lower bound. We want x is greater than or equal to 180. You want a very large upper bound. Now, the values of mu was 172. And then technically we had 29 as the standard deviation. Now, this 29 needs to be divided by the square root of n. So in this case, you have to do the following adjustment, divided by the square root of, in this case, 20. Let me close it up. And we're not going to match exactly to the previous answer because this z-score was rounded. So please take a second and round it and run it and see what you're getting. Now, doing the shortcut, which does not require the actual value of a z-score, gives us the following answer. Let me put actually both on the screen. In this case, using the shortcut, just going greater than, the probability of x is greater than or equal to 180, we're getting approximately 1087. So if you're asked to run these probabilities with the actual technology, you just have to adjust this portion here. Now, this portion is basically adjusting the z-score, and remember that the z-score in this problem C represents a group data. So in this case, the z-score gets modified not by having the values of sigma, but having sigma divided by the square root of n. So please take a look and see if you're matching with both of these possible answers.